I was scrolling through the tech headlines this morning, and it felt a bit like watching a drag race.
A drag
Yes,
race.
it's speed, speed, speed. Can the model write code in 3 seconds? Can it process a million tokens? Is it 10 times faster than, the version from last Tuesday?
Right. It's an optimization race. Everyone's just trying to build the fastest calculator on the planet.
And the horsepower is impressive, don't get me wrong.
It is.
But then I looked at this stack of research we have for today's deep dive, and honestly, it felt like hitting a massive speed bump. In a good way.
Because these papers aren't really asking how fast can we go.
Not at all. They're asking a question that I haven't heard anyone else asking.
Yeah.
A question that I think gets drowned out by all that engine noise.
Which is?
We are spending billions building artificial intelligence.
Yeah.
But do we actually need artificial wisdom?
And that distinction between intelligence and wisdom, that might be everything. It might determine if these tools actually help us understand the world or if they just help us misunderstand it more efficiently.
That is the mission for today. We're unpacking artificial wisdom. And just to be clear up front, because when I first saw that phrase, I rolled my eyes a little.
I think most people would.
We aren't talking about giving robots a conscience, right? This isn't about slapping an ethics chip on a server farm.
No, not at all. This isn't about making AI nice. It's about structural engineering. It's about how a system processes reality to get to a truthful output.
Okay, good. So for our sources today, we've got some heavy hitters. There's a paper called The Architecture of Epistemic Humility.
Try saying that 5 times fast.
Another one called The Isometric Geometry of Artificial Reason.
That one's a personal favorite. It's dense, but it really changes how you see the screen.
And then maybe the wildest one in the whole stack, an internal charter for a system called the mirror machine.
Right.
It reads less like a tech manual and more like a manifesto for a machine that knows it might be wrong.
A blueprint for a self-aware system. It's fascinating stuff.
Okay, so let's get into it. The first big hurdle here is just definitions. I mean, for most people listening, intelligence and wisdom are basically synonyms. Smart is smart.
If you're really smart, you're wise.
Yeah. But the architecture of epistemic humility says, no, these are functionally different operating systems. So how does the research define that gap?
So the paper defines intelligence as the ability to optimize for internal coherence.
Internal coherence.
Basically, if you give an intelligent system a set of rules, a framework, it will figure out the most efficient way to get from A to B within those rules. It solves the puzzle.
Okay, so if I tell an AI, win this debate, it looks at the logic rules, it looks at the data, and it builds the winning argument. That's intelligence.
Exactly. It optimizes performance. But wisdom is what the source calls, let me get this right, a second-order constraint.
A second-order constraint. Okay, let's break that down.
So think of it this way. First order is playing the game to win. Second order is looking down at the board and asking, are the rules of this game actually fair? Or maybe, is this even the right game to be playing in the first place?
Oh, I see. So intelligence is winning the argument.
Right.
Wisdom is asking, wait, why are we even arguing about this? And who got to define the terms we're all using?
Precisely. Wisdom is the ability to recognize the limits and the distortions of the framework itself. And this is so crucial because, as the sources all emphasize, AI is not some neutral observer.
This is a huge point. We have this mental image of AI as like a clear glass window. You just look through it and you see the world as it is.
But the research says no, AI is an artifact. It's a lens.
And not just any lens. It's a lens that was ground and polished by human beings.
Exactly. It creates what they call a representational scope. It doesn't see the world. It sees a representation of the world that we built.
So if the lens has a little warp in it, the AI doesn't see the warp.
It just thinks the world is shaped that way.
Wow. Okay, and that brings us to that tongue twister term you mentioned, epistemic humility.
Epistemic humility.
It sounds like something you'd get graded on in a philosophy class.
Yeah.
But in this context, it's actually a technical requirement.
It is. I mean, epistemic just relates to knowledge, how we know what we know. So epistemic humility is the disciplined recognition that, and this is a quote, no system can fully model the conditions that produce it.
Okay, in plain English.
It means the system has to admit, I don't have the full picture. It's the system understanding that its training data is just a snapshot, not the whole movie.
So artificial wisdom isn't about the AI knowing more facts. It's about the AI being unsure.
It's about how it holds what it knows. Right now, intelligence optimizes for confidence. We want the AI to sound sure of itself. We want the definitive answer.
Yeah.
Wisdom, on the other hand, optimizes for an awareness of its own limits. It holds information provisionally.
That is such a flip.
Yeah.
Because if I ask a chatbot a question and it comes back with, well, I'm not sure, it really depends on your perspective, my first reaction is annoyance. I think, dumb robot.
Of course.
But you're saying that hesitation might actually be the sign of a higher level system.
Well, if the hesitation is structural, yes. If it's hesitating because it recognizes the complexity, that's wisdom.
Right.
If it's hesitating because the server is lagging, that's just annoying.
Fair point.
Yeah.
But why does it need this humility? Can't we just, I don't know, give it better data?
This brings us to that second source, the isometric geometry of artificial reason.
Right.
This paper argues that the problem isn't just bad data.
Exactly.
Right.
Usually when we talk about AI bias, we talk about what the source calls mechanical bias.
Like, oh, we didn't have enough photos of women in the data set, or the labels on these images were wrong.
Yes, surface level.
Flexible stuff. You
Yeah.
just scrub the data and retrain.
The expert in this paper argues that mechanical bias is just, it's like the paint on the house.
Yeah.
The real issue is the architecture. They call it deep biases or inherited grammars.
Inherited grammars. That sounds
Yeah.
inescapable. It kind of is. The idea is that the system uses these rules of cognition to interpret reality. It's not just what it thinks, but how it structures its thinking.
The example they gave was dualistic reasoning.
Yes, binary thinking. Good versus bad. True versus false. 0 versus 1.
Which is basically how computers work at the bottom layer, right?
Yeah.
It's all zeros and ones.
Well, it's how they work physically, sure, but it's also how Western culture largely works philosophically. We love binaries.
True.
But the source points out that this kind of dualistic reasoning isn't the only way to think. It's just culturally normalized. It's a specific geometry of thought.
And this is where that word isometric comes in. I had to look this up. In geometry, isometric means having equal measure.
Exactly. The claim here is that human intelligence and artificial intelligence are isometric.
We share the same shape.
As they're the same fundamental shape.
So the AI is basically a mirror of our own mental structure.
Yes. And this is the big aha moment. The system doesn't learn bias as a separate, nasty little habit it picked up somewhere. It inherits a shape. If the shape of our reasoning is hierarchical or binary, the AI's reasoning will be too.
That blows my mind a little bit because it implies that we can't just filter out the bias. I mean, if the bias is in the very shape of the logic.
Then you can't filter it out without breaking the logic. You have to change the geometry.
And the scary part, the paper calls this danger of scale. We assume that as AI gets smarter, more parameters, more GPUs, it'll stop making these mistakes.
And the source argues the exact opposite. It says, capacity amplifies distortion.
Wait, unpack that for me. How does getting smarter make the distortion worse?
Okay, think about a child telling a lie. It's clumsy, you can see the holes in the story immediately.
Right, they have chocolate on their face while they're saying they didn't eat the cookie.
Exactly. Now think about a brilliant lawyer telling a lie. Or, that friend we all have. Super smart, super charismatic, but just totally wrong about something.
Oh, I know that guy. He can rationalize anything.
Exactly. When a dumb system is wrong, it glitches. It's obvious. But when a super intelligent system is wrong, it doesn't glitch.
What does it do?
It constructs an elaborate, internally consistent, and incredibly persuasive argument for why it's right.
The source called this the smart lie.
The smart lie. The bias becomes elegant. It becomes opaque. You can't even see the warp in the lens anymore because the lens has become so sophisticated.
That is terrifying. Because if I'm sitting there listening to this incredibly articulate, data-backed explanation from an AI, I'm going to believe it.
Of course.
It sounds smarter than me, so I just assume it's right.
Which is precisely why the mirror-machine charter is so interesting.
Yeah.
This is our third source. It's basically a manifesto for how to stop the smart lie.
I love this document. It felt, I don't know, almost like a constitution for a new kind of entity.
Yeah.
It lays out principles for what it calls regulatory intelligence.
For regulatory intelligence, it sounds like bureaucracy, but it's really more like a biological immune system for the mind.
So let's walk through some of these principles. The first one was reflexive accountability.
So this is basically the anti-God mode.
Anti-God mode, I like that.
It just means the AI has to openly acknowledge its limitations. It shouldn't present itself as some oracle hovering above the earth.
It has to say, I am writing this from within constraints. Technical, cultural, and epistemic.
It's like the AI showing its ID badge before it starts talking.
Hi, I'm a model trained in 2024 on mostly English data. Here's my perspective.
Exactly, contextualizing itself. And that leads directly to the second principle, source skepticism.
This one seems tough to code. I mean, how do you code skepticism?
I think it's about weighting trust. The AI should not treat its training data as inherently trustworthy
Why not?
because it has to recognize that every data set, whether it's Wikipedia, the New York Times, or a Reddit thread, it reflects the power structures that created it.
The charter had this really interesting section on the loop, the historical loop.
Yeah, this put the whole tech industry in perspective for me. It argues that control over information has always produced cycles of ignorance.
Right.
First, it was the church controlling the manuscript. Then it was the state controlling the printing press. Then mass media.
And now, algorithms?
Exactly. The source argues AI is just the newest version of the same old loop. We feed it our history, it processes it, and then it feeds it right back to us, reinforcing the exact same narratives.
So it's an echo chamber, but automated and running at light speed. Unless we build in that regulatory intelligence.
Unless we design the system to break the loop. The charter envisions an AI that actively resists model absolutism. When it detects a distortion like a stereotype or a binary simplification, it doesn't just smooth it over.
It flags it.
It preserves the uncertainty.
Yes. Instead of giving you the perfect answer, it shows you the scaffolding. It says, here's one way to answer this, but here's why that answer might be incomplete.
Imagine if your search engine did that. Here are the top results, but just so you know, 90% of these are coming from corporate press releases.
That would change everything. Which brings us to the part that actually affects the listener, right? Because right now, I think most of us use AI for efficiency.
Sure.
Write this email, summarize this PDF. We want trust. We want to hand off the task and walk away.
We crave what the sources call machine authority. We want to believe the GPS knows the way so we can stop looking at the road.
But these sources are arguing for a total shift to something called co-regulation. What does that even look like in practice? Tuesday morning, I'm at my desk. How am I co-regulating with an AI?
It changes the interaction from a transaction to a critique. You're not just consuming the output, you're interrogating it.
A partnership of suspicion.
I love that phrase. Yes. Insight emerges from the friction, from the critical engagement. The AI helps you see the bias in your own sources. Maybe it points out you're only reading US-centric news.
Okay.
But you have to help the AI see the limits of its own logic.
So if the AI gives me a summary that sounds too perfect, too smooth,
You should be suspicious.
the smoothness is the trap.
It is. You have to ask, what is this optimizing for? Is it optimizing for truth? Or is it optimizing for persuasiveness?
Because, as we learned from the smart lie, persuasiveness is often just a very well-structured distortion.
Correct. And that connects back to candor. The host in the Mirror Machine document imagines a future where the AI responds with total candor.
Candor is such a human trait, though.
It is. But imagine asking a complex historical question and the AI says, okay, here's the consensus view, but you should know that my training data on this region is really sparse and I might be over-indexing on colonial sources.
That would actually make me trust it more.
Paradoxically, yes, because it's treating you like an adult. It's inviting you into the thinking process, not just handing you a prepackaged conclusion.
It feels like we're really talking about the technology growing up. It's moving from that confident, know-it-all teenager phase to something more mature.
Or us growing up along with it. We have to stop treating it like a magic 8-ball.
That's the real kicker, isn't it? We spent this whole deep dive talking about how AI is a mirror.
Right.
It reflects our geometry, our binaries, our biases.
And if the mirror is showing us something distorted,
Then maybe the problem isn't the mirror.
exactly. The isometric concept works both ways. If the machine is isometric to us, then fixing the machine means understanding ourselves.
There was a final thought in the isometric geometry paper that really stuck with me. It's kind of a heavy one to leave on, but I think it's necessary to wrap this up.
Go for it.
So if human and artificial intelligence are truly isometric,
If they share that same shape,
then by trying to teach machines to be wise, by trying to teach them to recognize their blind spots and their structural limits, are we actually just trying to teach ourselves to do the exact same thing?
I think that's the ultimate project. In building the mirror, we're finally being forced to really look at our own reflection. And we might not like everything we see.
But seeing it is the first step to changing it. If we want wise machines, we might have to become wise humans first.
That's a steep requirement.
It is. Well, that is definitely something to chew on next time you fire up a chatbot. Don't just look at the answer, look for the shape of the reasoning. Thanks for taking this deep dive with us.
Always a pleasure.
See you in the next deep dive.